Here at the beginning of the course, I wanted to review some key concepts that you should have learned in your Introductory Statistics course. I'll focus primarily on inferential statistics, though I'll brush lightly over some descriptives as well. And I thought a really good way of doing this might be to start by looking at a study in the peer-reviewed literature and go through the results section of this study and kind of walk through the particular statistics that were run here. So as an introduction to this study, it's called, "Does this recession make me look black? The effect of resource scarcity on the categorization of biracial faces." And the way this study was run, there were 71 white undergraduate participants who were shown slideshows that primed them to believe that there was either an abundance of jobs and resources in the economy or a relative dearth or scarcity. And so they saw pictures like this that were like empty offices or empty stores, and they would read things about that said things like stores are going out of business. So some people were in this scarcity condition where they were primed to believe that there's not enough to go around. And other people saw slideshows that were filled with pictures like this that were a bustling office, and they had captions like there are plenty of good jobs. And after participants were primed with either a scarcity condition or an abundance condition, then the researchers would show them pictures of faces that were averaged together using a computer algorithm. And the way this worked, you can see here that if you had a white face here and a white face here, you could use the computer program to average them together into an amalgamation of the two white faces. You could do the same thing with two black faces. If you had this black face and this black face, you could kind of average them together into this middle face. But what the researchers did was they took one white face and one black face and averaged them together into something that looked like this. And then they showed participants 20 of these biracial faces that were artificially created to be absolutely, unequivocally 50% white and 50% black, because they were created artificially, not by genes, but by computer program. And so we knew that the researchers knew that each of these faces was 50% white and 50% black. And if people weren't biased at all, then when they were categorizing faces as either white or black, those were their only two choices. They couldn't say it's biracial. They had to say this face right here is white, or this face right here is black. And as they did that, if they were unbiased, they should have categorized 10 and 10, right? 10 white, 10 black, because that would be like flipping a coin. They're 50-50. There's no reason why they shouldn't have been categorized 50-50. So an unbiased research participant would have categorized them 10 white, 10 black. But in fact, what happened in this study, if you read the results section, was the number of faces that participants categorized as black was entered into an independent samples t-test with priming condition as the grouping variable. Remember, the priming condition was whether they saw the slides with abundance or scarcity. And then it says, as predicted, participants in the scarcity condition categorized more faces as black. They list here a mean and a standard deviation of the number of faces than did those in the abundance condition, and again a mean and a standard deviation. So let's just stop there. We won't go on to the rest of the findings here, but we'll take a look at what this means. The participants in the scarcity condition were saying more of the faces were black. Essentially what they were doing was they were saying here, if stores are going out of business and there's not enough jobs to go around, I don't want these people here that I'm viewing to be part of my group. I'm a white undergraduate and I want all the jobs for myself. So I'm gonna say this person here is black, and they're gonna force more of these people into the out group than they might need to. Okay. In the other condition, the abundance condition, where they read there are plenty of good jobs, they were more likely to kind of include them in their own group. I'm a white undergraduate, I'm going to say, sure, this guy can be white too. And so I'm going to categorize fewer of them as black, only about 8 of them instead of nearly 10 of them, right? So what we're finding here is that there's a difference in how people perceive the faces based on whether they think there's not that many jobs or whether there's lots of jobs. Alright, so let's take a look at what the data might have looked like then for these two conditions. We recognize that in a scarcity condition that people were averaging a mean of 9.35 faces categorized as black. So I've just made up some fake data down here, but I forced the fake data to average out to 9.35. So here in this condition, you can see the number of faces that people are categorizing as black could range from 1, or actually it could be from 0, but 0 to 20. And what that would mean is they were calling, here they would call every single face black. Here they would call 0 or only 1 face black. And here they're calling about 9 or 10 of the faces black in the middle. And most of the students were doing that. There were some that were, kind of more biased toward calling few of them black, more biased toward calling many of them black. But on the whole, on average, in the middle, we found that most people were about 50-50. Now, what was the mean of this group? It was 9.35, and that falls right there on that line. I've chosen to draw just a little bit above 9, so 9.35. That's the mean of this group. And of course, the standard deviation of this group is 2.8. And the way that we would represent that typically is to kind of draw an arrow to one side and perhaps the other side too, to reflect how far 2.8 points is. So 2.8 above 9.35 is that far, and 2.8 below 9.35 is that far. So this right here is the span of how far typically people are away from the mean of this group. Like within this span, that's where most people fall. There are, of course, some people that are outside of that standard deviation, and on either side, either on the upper or the lower side, but typically about 70% of the scores would fall within this bracketed range right there. I said here that there's an N of 35, and the reason I did that is even though the study didn't say exactly how many people were in each of these conditions, they did say there was a total of 71 white undergraduates. And so if you take 71 and divide it by 2, it's like 35, 36. So I just made up, I just made up here that this is about 35, and in the other condition, I'm just going to say there's 36, even though I don't know if it was exactly that way or if it was reversed or something like that. In the other condition, in the abundance condition, we found that there was a smaller mean, a 7.82. Here, I've just said that maybe this had an N of 36. It could have been 35, and maybe this one was 36 over here, but it doesn't matter. The mean of this group right here was 7.82, which I would write here slightly above 7, nearly 8, okay? 7.8 is nearly 8, and I would mark the mean of that group there, and the standard deviation at 3.15 would be 3 points above the mean on the right side and 3 points below the mean on the left side, and we could expect that about 70% of the scores typically fall within this range right here. Some of the scores are going to fall outside on either the upper or the lower side, but most of the scores will fall within one standard deviation to the upper or the lower side. Now here's the thing, we don't actually care about these particular 71 undergraduate students. There's nothing special about them. Instead, we're imagining that these 71 undergraduate white students represent a broader population of white individuals who were exposed not to PowerPoint presentations reflecting pictures of scarcity and abundance, but themes in the broader culture of scarcity and abundance, maybe news articles or things they've experienced in their daily lives. And so we're imagining that these samples of individuals who are white college students are actually representative of some broader populations of people. And we think that the populations of white people generally, when exposed to themes of scarcity or abundance, they're probably they've probably got mean scores if they were asked to do the same thing and categorize biracial faces as black or white, and they had 20 of them to categorize, that they would have categorized about 9.35 and about 7.82 in the actual population, that these sample means actually reflect something about the population. Now we recognize that sometimes the population might actually have a mean that's a little bit lower than the sample mean, sometimes that it's a little bit higher than the sample mean, but we would generally agree that whatever this sample mean is, that it's going to be very close to the population mean. And so we just represent that as if they're exactly the same, even though we know that our sample is never going to be actually exactly the same as the population. But further, it's kind of disingenuous for me to show these two graphs here as completely separate conditions, because these scores are actually overlapping. Like if you look at this scale here, this 1 through 20 is the same on both of the graphs. And so we should be actually overlapping these two graphs with each other and thinking about these two populations as potentially overlapping populations. And one of them, the mean of which is 7.82, is an abundance condition, where individuals in the broader culture might have been exposed to kind of themes of abundance, and they might be, if they were asked to do this, they would categorize about 8 of the faces as black. And the people in the scarcity condition would have, if they were asked to do this, would have categorized 9.5 or so of the faces on average as black. And if we look at these two populations, then we're imagining here that that it's possible that there is a real difference between the amount of faces that people in the population would have categorized if they're kind of like attuned to the idea of scarcity, or if they're attuned to the idea of abundance in the general population. I'm going to get rid of these graphs down below for a second, because I think that what our inferential statistics here are doing depends almost entirely on this abstract notion, this idea of these general populations, not actually about the samples. Now, we're computing statistics based on the samples, but what we're doing is supposed to be about these imaginary populations that are represented by the samples we've drawn from the populations. So what we have here is these two imaginary populations with a mean of something very close to what the sample means were, and we compute some mean difference here, and the difference between 7.82 and 9.35 is a difference of 1.5. And if we were to draw individual people from the scarcity and the abundance conditions over and over again and compare how far apart those people are in this categorization of biracial faces task, we would find that on average they were about 1.53 units apart, faces apart. And if we were to plot an entire distribution of all of the different scores between different samples from these two populations, we would find, if this was a real difference in the population, that the mean difference for all of the different samples drawn from the one population versus the other population, and the difference computed between them, it would be a difference of about 1.53. Now, that's assuming, of course, that there actually is a difference in the population of 1.53. If this were a bigger or a smaller difference in the real populations, then this would reflect that. But we don't know how much it is. We're just guessing based on the sample characteristics that we've drawn for this particular study. This right here represents what we call the alternative, or the research hypothesis. And you remember that the way we write this out is to say the mean, the mu, of the population of all the people who are primed by abundance themes is not equal to the mean of those people who were who were primed by themes of scarcity. And so these two means are not the same. We would represent that visually here by saying that this population mean and this population mean are separated from each other, that those populations are not the same. Okay? But There is another research hypothesis that we sometimes talk about, and we call this one the null hypothesis. We represent it as H sub 0, and that means nothing, nada, there's nothing going on here, there is no difference. The mean of the abundance condition is equal to the mean of the scarcity condition. And so how that would look is you can imagine that these two populations here are not actually different in real life. In the real world, this mean isn't 7.82 and this one 9.35. They're actually both the same, something like 8.5. And these therefore have to meet in the middle, and you'll see there that you've got two identical populations. One of these populations were the people exposed to scarcity ideas, and the other one were the people exposed to abundance ideas. But it doesn't actually have an impact in this imaginary scenario on how many faces they categorize as black. And so they're going to end up categorizing about 8.5 faces, regardless of which of the two conditions they were in. In this condition, if this were actually what was going on in the world, then when we compute the difference on average, it would be nothing. There would be no difference. Again, the mean of the abundance condition would be equal to the mean of the scarcity condition. There would be no difference. And if we drew sample after sample from both of these populations and compared the difference between them, and we plotted a sampling distribution of all those differences, it would average around 0. There wouldn't be any differences on average. Sometimes we would find differences between our samples. They might be a few points higher than 0 or a few points lower than 0, but it wouldn't be much. This right here is the null hypothesis. When we compute a t-statistic, what we're doing is we're taking the mean of the one group in our sample and subtracting from it the mean of the second group in our sample and dividing it by the standard error of the mean. You remember that the mean of the first group in this condition is 9.35, the mean of the other group is 7.82, and if you subtract those out, the difference, as I mentioned previously, is 1.53. You divide that by the standard error of the mean, which is the distance of a standard deviation in the sampling distribution. I don't care right now if you remember how to compute this. At some point later in the term we'll talk about this, but for now it's enough for me to just remind you that this distance right here, the standard deviation of the sampling distribution, is how much your standard error is. And so you take the raw distance between your two sample means, and then you divide it by how much this sampling distribution is typically falling away from the mean, and you figure out how much bigger is our distance than we might typically expect there to be away from the mean of 0 just by chance. That's what this represents. Just by chance, how far should we expect our means to, our sample mean differences to fall away from the sample mean? And we compute that out to be 2.16. We can plot that in our sampling distribution here. It lands somewhere far out here. Remember, you should have learned in your introductory statistics class about z-scores. Z-scores are very similar to t-scores. A z of 2.16 or a t of 2.16 would fall about 2 standard deviations above the mean. And then we have to draw a conclusion about this t, the fact that it's a 2.16. So again, the null hypothesis is reflected here by an illustration like this, where both of the populations are identical to each other, there is no difference on average, and the standard error, the sampling distribution reflects that there is no difference. We would compute our t and plot it here. The alternative hypothesis is that there is a difference, they're not equal. And that would be reflected, like I showed you before, in the fact that there's two populations with different means, maybe something close to what our sample means were, and that when we compute the difference between them, there actually is a difference. And if we computed a sampling distribution here, we would find that that sampling distribution centers around something that's other than 0, some difference, like 1.53. So we plot in our null hypothesis sampling distribution, our t of 2.16, And we look at that and we say, what's the probability of getting a t that large? It's out here in the extreme tails. That's very unlikely. We don't usually get that just by chance. And in fact, the probability here is 0.034. That was given in the research results. The probability of getting a t that big is 0.034. That means only 3% of the time would you find a t out here in the edges of the tail like this. So we could say it's possible that in reality, the null hypothesis is true. There is no difference between these two different kinds of priming conditions of scarcity PowerPoint slides and abundance PowerPoint slides. And that what happened was we just got an extreme difference between them just by chance. It might have been this 3% of the time. But since it doesn't happen that often of the time, that's unlikely. More likely, this t is actually in the middle of a distribution of scores where there's a true difference in the populations. And we computed the size of that difference, and that difference falls in the middle of this distribution somewhere, like maybe a little lower, maybe a little higher. But the point is, it would fall somewhere within this alternate distribution, this alternate research hypothesis distribution. And so, in a situation like this, we would then reject the null hypothesis. We would say this right here is unlikely. We don't think this is one of those times when just by chance we could have maybe 3% of the time got this. We don't think it's that 3% of the time. Probably more likely, this is a real difference, and we have to accept that there are actual differences in the populations of people who are primed by scarcity and abundance. Now, the last thing that we see reported here is what's called a Cohen's d, and that equals 0.51 in this condition. But what Cohen's d reflects is if you take that distance between your two sample populations, your two sample means, but we're imagining that those reflect the two population means. If you take the difference between them, that 1.53, and you divide it by the standard deviation that you're finding here in your populations, then what you're left with is that distance right there, 1.53, divided by your standard deviation of the populations, and you get 0.51. And we interpret this number right here to mean that the distance between these two groups is about 0.51 standard deviations, or about a half a standard deviation apart. That's a moderate size of Cohen's d. And when we see these kinds of results, this suggests again that these are unlikely to have happened just by chance, that there probably is a real difference in the populations between people primed by scarcity and abundance in their degree of relative racism, or their willingness to accept other people that are different from them within their same group. And how big of an effect is that? It's a moderate size effect. And that's the kind of stuff that I'm hoping you'll remember from your introductory statistics class as we begin our new term here.